everyone. Thank you for joining us today for Spokane Public Schools Keep Learning series. Today's lesson is meant for fourth graders, but anyone is welcome to join. My name is Amber Smith, and I'm a teacher at Finch Elementary School in Spokane Public Schools, and I'll be your teacher for this lesson. I'm really glad that you get to join us today. Now, if you haven't seen the other lessons that we've been posting, you can go to the KSPS website, and I think it's always helpful to go back and rewatch those so that you can get better at the concepts and just help remind yourself of what we're learning. Today, we're going to focus on learning about 2-digit by 2-digit multiplication using the partial product method. You're going to need a couple pieces of paper, a pencil, and your fabulous brain, and we'll get started.
All right, before we get started on our lesson today, let's do a little warm-up. And I thought a fun one for us to do today would be a round of catch that mistake. So catch the mistake. So I have a problem here for you, and I want you to look it over for a moment and see if you can figure out what is the mistake in this problem. All right. Have you spotted it yet? If you haven't spotted it, let me see if I can help you out a little bit. The person who solved this problem wasn't quite paying attention to the subtraction symbol. And this is a pretty common mistake where people will look at a problem really quickly and think that it's addition, but it's really subtraction, or the other way around. So this problem was solved incorrectly because they added the two numbers instead of subtracting them. So let's go ahead and fix it. So I'm going to rewrite the problem so we can solve this correctly. So we need to subtract. So the correct answer should be 3001 because we needed to subtract and not add. Let's look at one more. All right, so we have 3,000 times 5 equals 1,500. Can you catch the mistake? I'll give you a few seconds to look it over. All right, so do you see it anywhere? Are you noticing that this number is smaller than that number? How is that possible if we're doing multiplying, which means that we are probably getting bigger? So 3,000 times 5, I know that's 3 times 5 is 15, so the beginning of the problem is correct. But what would I need to add to this answer in order to make it 100% correct? I can think about it this way too if I'm struggling. And I can write out the 3,000s 5 times if I need to. Let's see what happens when we add down the columns. 3, 6, 9, 12, 15. Aha, there it is. It's a place value error. We needed one more 0 on that. All right, I always think playing catch that mistake is a little bit of fun, and it helps your brain grow when you catch your mistakes. Always check your work. All right, we're going to continue with our practice with partial product in solving 2-digit by 2-digit multiplication problems. The first problem we're going to practice today is 51 times 26. So I'm going to slowly take you through the steps of what you need to do, and to make sure that you are fully understanding how to be successful with the partial product method. So my first step is, let's set it up in standard algorithm, like this. My second step is I need to do some multiplication. So I'm going to move from right to left. I'm going to go up and down and solve 6 times 1, which equals 6. I'm going to go diagonally and go 6 times 50, which equals, let's think of 5 times 6 is 30, but I have an extra 0, so that's 300. Then I need to do a 20 times 1. Anything times 1 is itself. And then my last step is up and down this way, 20 times 50. So our first step is set it up in standard algorithm, and then you have the 4 multiplication problems you need to do. So up and down, crisscross, and then another up and down. So 2 times 5, I know that's 10, and then I just need a couple more zeros to make 1,000. Our last step is to add the numbers down the columns. So we go 6, 1,326. So remember, step 1, set up in standard algorithm. Step 2, multiply the 4 problems, so going up and down and crisscross, and then add them up. Our next problem, I'd like you to do this one with me, is 81 times 90. Now this one's a little bit different because we have this 0 in here, and zeros can be a little tricky sometimes when we're doing these kind of problems. So let's look and see what happens when we do this. So my first step after putting it in standard algorithm is to do the multiplication problems. So my first one is 0 times 1. Well, 0 is nothing, so that's nothing. And notice here, I have 0 times 80. Again, that's nothing. Now I can go 90 times 1 equals 90, because it's anything times 1. And then my very last one, 90 times 80. That's the toughest one, isn't it? So I'm thinking of my facts. I know 8 times 9 is 72. And then I've got a couple zeros on there. And then do you remember what our last step is? Our last step is we need to add up and down the columns. So that one's a little different because of these zeros in here. So the zeros, anything times 0 is going to be 0. So you have less to add. I really only had these two numbers, the 90 plus the 7,200 to add together for that problem. All right, so always be careful of those zeros. Let's look at one more that we can practice today. 62 times 75. So I want you to write this one on your paper. Think of what is the first step that I need to do. I'm going to pause for a few seconds and let you think about what is the first thing that you need to do. Okay, so hopefully you're remembering that you need to set it up in standard algorithm of 62 times 75. So there's step 1. Okay, so step 1. Get it set up. Step 2, what's that? Can you remember what the process is? What do you need to do? So step 2 is our multiplication part. So we need to start here. 5 times 2. What do you get for that? Is that a pretty quick one? Is that a snap fact for you? You should have 10. What's the next step? Where do I go from here? You should be thinking that you go from 5 times 60. 5 times 60. So think of 5 times 6. But you got a 0 on the end. Can you think of what that is? And write it down. I know 5 times 6 is 30. And we've got that extra 0 in there. So that one more shift of place value. What's the next step? Now where do we go? I'm hoping that you're saying, hey, I need to go over this way. I need to go 70 times 2. I can think about that like this if I need to real quick. right? 140. And then my very last step, what's the last problem that I need to do? I'm hoping that you're saying you need to do this. I need to do 70 times 60. I'm thinking of 6 times 7 is 42. And then I've got those multiplying by 10 2 times. So this is what I should have. How'd you do? Are you feeling pretty successful with that? What's your last step that you have to do? What would step 3 be? All right, step 3 is add them up, right? So let's go down the columns and add up those numbers. And we got 4,650. All right, so what you need to remember for partial product with 2-digit by 2-digit numbers is step 1, set it up in standard algorithm. Step 2, multiply together, up and down, crisscross 2 times, and then up and down again. And then step 3, add all these up. Make sure when you add up that they all line up on this side so that everything is in the right place value spot and you don't make any silly mistakes with adding up. Now, on your own for practice, I'd like you to write down these 4 problems. You have 71 times 35, 42 times 91, 64 times 33, 54 times 18. Check with your teacher how you could communicate your answers to these problems with your teacher and show your learning of this concept. You can check your work with a calculator, or you could do the area model to check your work as well. You could work with your parents on checking them as well. I have really enjoyed doing some of this math work with you today, and thank you for joining me from your home. I look forward to seeing you again for our next lesson on KSPS, and if you're looking for more activities, they can be found on the Spokane Public Schools Learning from Home website. Have a great day.
Hello, mathematicians. I'm Miss Hegman, District Math Coach for Spokane Public Schools. Today, I'm going to show you how to play a fun math game called Bowl-O-Fact. For this game, you will need paper, a pen or pencil, and a 1 to 6 die. This activity is adapted from a website called YouCubed, which has all sorts of fun math tasks and activities. The first thing you'll do on your piece of paper is to draw 10 circles in the same placement as bowling pins, if you've ever been bowling. It's like a triangle with the tip pointing to the bottom of the paper, just like the one you see here. After you've drawn your 10 circles, then write the numbers 1 to 10 in the circles, as shown. The next thing you'll do is draw 3 boxes to the side of your 10 circles. You will roll the die 3 times and record the digits. As you can see here, the first time I rolled a 4, then I rolled a 3, and then I rolled a 4 again. If you don't have a die, you can take some little pieces of paper and write the numbers 1 through 6 on the little pieces of paper. Then you can put those pieces of paper into a hat or a bowl, and you can reach in and pull a number out, and whatever number you pulled out, you write in the box, and then put it back in, mix them around, pull out again, write that number down, so that you get your 3 numbers to write in your boxes. Once you have your 3 numbers, you can work with a partner or you can work by yourself, but you're going to write number sentences using only those 3 digits that you wrote in the boxes that equal as many of the numbers 1 through 10 as possible. You can use addition, subtraction, multiplication, and division. You must use all 3 numbers, and you can only use each number one time in the number sentence. My first number sentence was 4 plus 4 minus 3 equals 5, because I know that 4 and 4 is 8, and 8 subtract 3 is 5. And then crossed off the 5 bowling pin. My next number sentence is 4 minus 4 plus 3 equals 3. Because I know 4 minus 4 is 0. And then add 3, you get 3. So then I crossed off the 3 bowling pin. Then I had 4 times 3 divided by 3 equals 4. Because I know 4 times 3 is 12. And then 12 divided by 3 is 4, because there are 3 4s in 12. So then I crossed off the number 4 bowling pin. I could not come up with any other number sentences that equaled the other numbers on the pins. I wonder if you can. Guess it's time for the next bowling ball. Just like when you're bowling, you get to use the bowling ball 2 times to try to knock down the pins in what they call a frame. Well, this is going to be our second bowling ball. So I drew those 3 new boxes next to my other boxes, and I rolled a 5, a 2, and a 1. And again, if you don't have a die, you can use your little pieces of paper just like you did before. Now we're going to see how many more numbers we can cross off. So I did 5 times 2 times 1 equals 10. Because 5 times 2 is 10, and 10 times 1 is 10. So I got to cross off the 10 bowling pin. Then I did 5 times 2 minus 1 equals 9. 10 minus 1 is 9. 2 times 1 plus 5 equals 7. 2 times 1 is 2, and 2 plus 5 is 7. 5 minus 2 minus 1 equals 2. Now my last number sentence here, I decided I was going to start with 5 minus 1. So I put those in parentheses because I know 5 minus 1 is 4. And then I multiplied that by 2. And that equals 8. So I was able to cross off all of the bowling pins except for 1 and 6. I wonder if you could find a number sentence that I didn't that would equal 1 or 6. This is a fun game to play, and you can play it anywhere. And if you have little brothers and sisters, you could play this just using addition and subtraction. Bowl-o-fact is a fun way to think about numbers and to use operations of multiplication, division, addition, and subtraction. Mathematicians, have fun playing Bowl-o-fact.